All right, so we're going to talk about some story problems involving these logarithmic equations, exponential equations, and some very, very relevant applications with these guys. And I've mentioned before with these, when we started talking about exponential and logarithmic stuff, that there's a lot of uses in science with growth and decay. It mentioned in finance, compound interest, things like that, and that's what we're going to take a look at today. So the bottom line is there are three formulas that get us into working with exponential functions or logarithmic functions, depending on what we want to solve or figure out. And you're going to have to differentiate between the three. Here in the notes, we'll label them for you. On the test or a quiz, we will not. And so you've got to be able to pick out which one you want to use and when. The first one here is anytime we want to talk about appreciation, depreciation, or growth and decay annually, right? If we're talking about annual, then this is the formula. Appreciation, of course, means that anytime you buy something and it grows in value. Depreciation means anytime that you buy something and it decreases in value. Cars are a good example of that. The second you drive a car off the lot, it automatically depreciates. It loses its value. Growth and decay means what it means, right? If population of anything, cells or microorganisms or anything grow, or if like an isotope half-life or medication half-life would be an example of decay. As long as we're talking about an annual growth and decay or an annual appreciation, depreciation, then we're going to use this formula. Y equals C times 1 plus or minus R to the T. Now, what does all these mean? Y is your final amount. C is your initial amount. R is rate. And we're always going to put rate in as a decimal. It'll usually be reported as a percentage. We want to put it as a decimal. And notice that there's a plus or minus in here for the R. The plus or minus doesn't stay. The reason why it's there now is if we're talking about growth or appreciation, where we're increasing something, we want to make that plus. Anytime we're talking about decay or depreciation, then we want to make that a minus. Anytime we want to lose value or lose population or whatever. And then, of course, T means time. Okay? So, for example, if you're looking at a story problem like this, it says you buy an antique table for $1,500 on an auction. It is estimated that the table will appreciate at a rate of 3% per year. How much will the table be worth after 25 years? Now, the words that we're looking for here are appreciate and per year. That's going to let you know that one, we're using this particular formula, and two, that it's an appreciation, and we want to do the plus R, not the minus R. So we need the formula Y equals C times 1 plus or minus R to the T. It'll be a little bit more confusing when we add the other two formulas in here. So now all we got to do is pick out the different pieces. $1,500 is going to be C. That's your initial amount. The rate R is 3%, so we're going to put it in as a decimal, 0.03. And we want to know how much the table will be worth after 25 years. That's going to be T. So we're trying to figure out Y when C is 1,500. 1 plus 0.03 to the 25th power. Okay? And this is where you got to get it into your calculator to where it makes the most sense. So obviously we can do some quick mental math. This is going to be 1.03. Now just raise that to the 25th power and multiply it by 1,500. And you will discover that this table will be worth $3,140.67 in 25 years. Okay? So once you pick out the formula, it's just plugging stuff in, and it shouldn't be a big deal. All right? The next formula is anytime we're talking about compound interest. Compound interest means that when you put money in the bank, say, in a savings account, $100, then the bank might pay you every quarter, every 3 months, might pay you some interest. and then it takes that money and adds it to your initial amount, say $100. And then the next 3 months, at the end of the next 3 months, it'll pay interest on, let's say you got $5 in interest the first 3 months, now you have $105, then it's going to pay you interest on $105 instead of $100. So it's going to keep building that initial amount and pay you interest on whatever that new initial amount is. Okay? This particular formula we use if we're compounding interest a certain number of times per year. Different than if we're compounding interest continuously, which we'll see in a minute. So here's your formula. A stands for the final amount. P is the initial amount that you put in. R is your interest rate. T is time, and N is the number of times that they're going to pay you per year. Number of times is going to be compounded per year. And it might differ. It might be an annual compound, might be semi-annual, might be quarterly, might be monthly. And so we've got to know what that means in terms of how many times you're going to get paid. So I think this will make a lot of sense, but obviously if you get paid annually, that's 1 time per year. So N is going to be 1. Semi-annually means you're going to get paid 2 times per year, which means N is going to be 2. Quarterly means that you're going to get paid 4 times per year, so N is going to be 4. And obviously monthly means you're going to get paid 12 times per year, which means N is going to be 12. Okay? So we got to keep that in mind as well. All right, so an example of this. If you invest $4,000 for 3 years at 6% compounded quarterly, okay, how much money will you have at the end of 3 years? When it says compounded quarterly versus what we'll see in a second as being compounded continuously, then we want to use this formula here that we just took a look at. Okay, but those are the words you're looking for. So you've got your initial investment, so that's going to be P, $4,000. Obviously, 3 years is your time or your rate. Time. 6% is your rate. If it's going to be compounded quarterly, then that means that you're going to get paid 4 times per year, and so N needs to be 4. And that's what we will want to plug in. We want to know how much your investment will be worth, right? So we put in 4,000 for P. Since we're always adding money when we compound interest, there's no plus or minus here. It's always plus. So the rate is 0.06 over 4, and we're going to raise that to the 4 times 3 power. And again, do some arithmetic to get whatever you need your to get whatever you want to put into your calculator to get this. You can divide the 0.06 by 4 and get 0.015, and this is 12. And so you can add the 1 to that, and that's what you're going to put into your calculator. So 1.015 raised to the 12th power, and then multiply by 4,000. And that'll get you your new amount of $4,782.47. Okay? All right. So again, pick out the right formula, and the numbers to plug in should be pretty easy. Next one says that you invest $6,500 at 6.6%. Compounded monthly means that we're not compounding continuously. And so we want to use this second formula. This guy right here. Okay? Now, $6,500 is your principal amount. 6.6% is obviously your rate. Question is, how much money would you have after 2 years? And so 2 is going to be your time. Since you're compounding monthly, you're getting paid 12 times per year. So, $6,500 times 1 plus, remember to put this in as a decimal, so you got to move the decimal place over 2 spots to the left to get 0.066, and we're compounding 12 times per year. So we've got 12 times 3 in this exponent as well. Okay? And so work this out. And so you got 1 plus 1.0055. This is 36. So you got 1.0055, and we're going to raise that to the 36th power and multiply by 6,500. So you now have $7,918.96. The second question is, how much interest would you have earned during that time period? Well, since you started out with $6,500 and now you have $7,918.96, all you got to do is subtract the $6,500 that you initially put in there to find out how much interest you earned, and the interest is $1,418.96. Okay, make sure I put everything in there correctly. Oh, I didn't. Okay, so I wondered where that number came from, but the years were actually 2, so this should have been 24. All right, we got to change a few numbers here real quick, not a big deal. So you actually would end up with $7,414.52, which means that your interest earned would have been $914.52. Okay? Sorry, just a wrong number there. All right, so I mentioned before that if you're getting compounded a certain number of times per year versus being interest being compounded continuously, then you're going to use a different formula. So here's our formula if we want to continuously compound your interest, or if your growth and decay is happening continuously, not necessarily just once a year, right? So anytime you see the word continuous, then you're going to want to use this formula, and this is where the E comes into play. I mentioned that before. We started talking about our natural logarithms and our natural base. This is the type of interest that Bernoulli and Euler were studying when they discovered this constant E that we now use as an irrational number. Okay, but everything kind of looks to be the same. A is your final amount, P is the original amount, and then R is rate, T is time. Now, we are talking about growth and decay, so we need to be able to reduce amounts and increase amounts depending on what's going on. And the way we do that is, if we're talking about decay or losing numbers or amounts, then we want to use a negative R. And if we're growing, we want to use a positive R. So make sure that you're paying attention to that as well. Okay? All right, for example, if your problem says something like a certain organism grows at a rate of 42% per day, right? The science lab started the school week with 30 organisms. How many would they have on Friday? So growth and decay, we talked about with the first formula, but that was per year. This is per day. So since it's not per year, we want to use our formula that we just talked about now. A equals PE to the RT. Right? Our final amount is A. That's what we're trying to figure out. Our initial amount was 30. We want E, and it's growing, so our rate is going to be positive, so we're going to use 0.42, positive 0.42, and we're going to multiply it by time. Now, make sure you pay attention. The start of the school week is Monday, and then from Monday to Friday is 5 days, so we want to use 5. Right? And so we just want to take 30 times E to the 2.1 power. We should be able to do that. And on Friday, there should be 244. Now, you get 0.99, but you can't have 0.99 organisms. So you're going to have about 244. Okay? All right? Another type, right? If you invest $2,000 at 4.8% compounded continuously, there's that word again, how much money will you have after 5 years? That continuously word means that you want to pick up this formula right here. A equals PE to the RT, where P is $2,000, your R is 4.8%, and your T is 5 years. right? And again, since we're always adding, when we're talking about interest, we want our rate to be positive, of course. 0.048 times 5, right? So that's $2,000. 0.048 times 5 would give you 0.24. So we want to take 2,000 times e to the 0.24. And the amount that we'll have after 5 years would be $2,542.50. Okay? All right. Now, sometimes you'll need to find something other than the final amount. Might be the rate, might be the time. That's where we start getting our logarithms, bringing our logarithms into play. And so let's take a look at what some of those problems might sound like in our story problems. Right? So, for example, this one. A $40,000 car depreciates at a constant rate of 12% per year. In how many years will the car be worth $12,000? All right, well, the first thing we got to do is pick out the right formula. And so some things you want to look for. Depreciates and per year. Since it's per year, that means that we're going to pick up that first formula, right? And then just fill in your amounts. Where $40,000, if you buy the car for $40,000, that's your initial amount. That's C, right? The car now is worth $12,000. That's your final amount. That's Y. So you actually want to plug $12,000 in for Y. Then now we're talking about depreciation, so we want to subtract the rate, and we're trying to find time. Right? So we're going to do a little bit of arithmetic, divide both sides by 40,000. And you get 0.3. 1 minus 0.12 is 0.88 to the t power. And if we're going to solve for t, we're going to get t out of that exponent. And so the other way to look at this is I've got an exponential equation, but I cannot get base 0.88 on both sides. So I'm going to need to rewrite this as a logarithm. So I need a logarithm with the same base. So logarithm of 0.88. And then these guys switch. So 0.3 comes over here. T comes over there. And now we're going to use our change of base, which would look like log of 0.3 divided by log of 0.88 to find out the number of years of the time here. Make sure you put parentheses around your 0.3. And you get 9.4. So, in other words, in about 9.5 years, the car will be worth $12,000. Okay? Picking out the right formula, though, is most of the battle here. Number 8, an organism of a certain type can grow from 30 to 195 organisms in 5 hours. Find the rate in which the organism is growing. Now, we're talking about growth in 5 hours, not in a year. So that means we want to use that last formula, right? And so, A is your final amount, that's 195. P is your initial amount, that's your 30. We're talking about 5 hours, that's your time. And we're trying to find the rate. And so your formula would look like this. Okay? Divide 30 into both sides. You're going to get 6.5 equals e to the 5r. Now you can't get base, you don't have base e on both sides, so we've got to rewrite this as a logarithm. The logarithm with base e is the natural log, and then we want to flip-flop these two. So 5r comes on this side of the equation, 6.5 comes over here. So now we want to type in natural log of 6.5 and divide it by 5. And you get 0.374. Remember, we're looking for a rate. So that rate turns into 37.4%. Okay? So there you go. All right? Number 10. Carl plans to invest $500 at 8.25% interest, compounded continuously. How long will it take for this money to triple? Compound continuously. Continuously means you want to use that last formula. okay, where he's wanting to triple his money. Well, he started at $500. If he's going to triple it, that means we got to multiply it by 3. So $1,500 is your final amount. We want to know how long. We've got the interest, which is 0.0825, and we want to find the time, right? Obviously, if you divide 1,500 by 5, you're going to get 3. So there is a shortcut there to be found if you want to look hard enough. But I'm going to stick with just writing out the amounts. Right? Again, we don't have an e on both sides, so we've got a natural log, and then flip-flop these. Natural log of 3 equals 0.0825t. So take the natural log of 3, divide it by 0.0825, and your time is 13.3, so a little over 13 years is how long this will take. Okay? All right, still looking to pick out the right formula. So another one here. Take a look at that and see if you get use the right formula. And stop the video, start it back up, and see if you're right. So you should get 5.58 years, about 5.5 years. Okay? If you didn't get that, make sure you come in. Make sure you come in and get help. Okay? I'm going to show you the next one. Oh, that's it. So if you didn't get that, make sure you come in and get help. And otherwise, try the homework out on campus. We'll see you next time.